Good day, viewers. This is Afenimola Johnson, your science tutor. So we are continuing from Aufbau's principle. In the previous video, we started talking about laws and principles guiding the electronic configuration. We are talking about ascent badge uncertainty principle. We are talking about Aufbau's principle. Now, I want to look at, don't forget from the Aufbau's principle, we are able to arrange orbitals. Don't forget this arrangement. You say K shell contains one s orbital, L shell contains what? 2s and 2p. Then M shell contains what? 3s, 3p and 3d. Then N shell contains what? 4s, then 4p, 4d and 4f. So don't forget these arrangements. We have done that in the previous video. You can watch out for it. Now, we want to look at the application of Aufbau principle that we have discussed to write the electronic configuration of the first 30 elements. The first element is called hydrogen. Hydrogen, and the atomic symbol is H. Don't forget, we have also done the very first video we did, the configuration of hydrogen. You know, this is you have K, L, M and N. Because it has only one electron, that electron fills this place. And when we are writing the SPDF configuration, don't forget, every s orbitals carry maximum of 2 electrons. Then every p carries what? 6 electrons maximum. Every s is 2 electrons. Every p carries 6 electrons. Take note of that. Every d carries 10 electrons. Then every s 2 electrons. And every p carries 6 electrons. Then every d carries 10 electrons. Like that. And every f carries what? 14 electrons. And now, what is the shortcut to know this? You have S, P, D, F. Every S carries maximum of 2. This is the only one you need to memorize. Begin to add 4. Add 4 to 2. You have 6. Add 4 to 6. You have 10. Add 4 to 10. You have 14. So it does not matter the coefficient of S. So far it is S. It carries maximum of 2. Whether it is 1S, whether it is 2S, whether it is 4S, whether it is 5S, S is S. Whether it is 3S, they carry maximum of 2. P's, they carry 6. Now, because hydrogen has only one electron, and Aufbau principle says that you must fill 1s first because it has the lowest energy level. It says when filling orbitals of the same subshell with electrons are first fully filled into orbitals with lower energy level, and 1s has lower energy level. So we put 1s. The 1s is supposed to carry 2 electrons, but it cannot kill itself. It is only 1 electron that is available. So we write it as 1s1. So the SPDF configuration for hydrogen is 1s1. Number 2 is helium. Helium He, having 2 electrons. Now the configuration says 2 stays here to 1. 2. The configuration, the K element, we said that K shell cannot take more than 2. This one take 8. This one take 18. This one take 32. Now, then to write this, now the rule says fill this one first. 1s can carry 2 and there is 2 electrons. So that is that for helium. Then we are done for that. Number 3 is lithium. Lithium Li. That's 3 electrons. The 3 electrons will be written as what? 2:1. So 2 to K shell, 1 to L shell. Then to write the configuration, we start with what? 1s. He said you must fully fill it with, you can carry 2, so put the 2. So the remaining one now, you cannot go to what? 2s. You don't have 2s. The 2s can carry 2, but it's only one that is remaining. So we put it there. You have 1s2, 2s2. Then the next one, number 4, is beryllium. Beryllium Be. Now, beryllium Be configuration is what? 2 to 2. And to write the SPDF configuration, we want to fill 4 electrons. So put 2 into 1s. It remains 2. Then go to 2s. You have 2s, then put the remaining 2 there. So that's what you have. So then we have, next one is boron. Number 5 is boron. Boron B. So boron has 5 electrons. That's 2:5. Can watch the first video. That's part 1 of this series. To get this K element share. Then, for us to put 5, this is 2 to 3. 2 to 3. Then, to put 5, 1s will take 2. Remaining 3. 2s cannot take more than 2 out of the 3. The remaining one will now go to what? 2p. 2p1. Although 2p can carry 6, but it's one that's available, it will manage that one like that. So, then the next one is carbon. Carbon C, 2 to 4. Then the configuration will have 1s2, 2s2, 2p2. Now, then we have nitrogen. Nitrogen N, which is a 2 to 5. Will now be 1s2, 2s2, 2p3. Then the next one, number 8, is oxygen. Oxygen O, which is 2 to 6, will now be 1s2, 2s2, 2p4. The next one is 9, fluorine. Fluorine F, that's 2:7. Then this is 1s2, 2s2, 2p5. There is something I want to explain to you now before I will rub off this board. We have done relationship between shell and orbitals. Now, this one, what's the relationship between this one and this one? This one is carrying 1 electron. That 1 electron is staying inside 1s orbital. These 2 electrons, they are staying inside 1s, inside K shell. So now we can say here, we can see this one now is what? K shell. This one now is what? Also K shell. Now, this one is what? K shell, K, while this one is L. So, K and L. Now, so this one now is what? K and L. Because this one alone is K shell. This one and this one are L shell. That's why when you add this 2 plus 1, you have this 3. Take note of that. So this one now is what? Is K shell containing 1s orbital carrying 2 electrons. This and this are L shell. 2 plus 2, 4, which is this 4 valence electron. This is K shell. This and this is L shell. 2 and 2. Don't forget, principal quantum number for L shell is 2 and 2. This is K shell. And this one is L shell. 2 plus 4. That's a what? 6. That's this 6. So this is K shell. Then this is L shell. 2 plus 5. That's 7. That's how we got this 7. So please take note of that. Now, let's move on to okay. Now, we are going to just talk about fluorine. Now, okay. So, number 10 now is neon. Neon Ne. The configuration is 2 to what? To 8. Then the configuration, want to put 10. The rule says 1s2 out of 10. Remove 2 from 10. You have 8. You now go to the next one is what? 2s. 2s cannot take 1 and 2 out of the remaining 8. Make it 2 plus 2, that's 4. Remove 4 from 8. You have 4 left. So what do you have? Then you move here 2s. 2p, sorry. Anything p can carry 6. So we have 6 here. 6, 7, 8, 9, 10. Can you see that now? So in that place now, our K shell, this is our K. While from here to here is our L shell. So that is that. 2 plus 2, 8. 2 plus 6, 8. That's how we got this 8. This 2 is this 2. So we have gotten that. Then the next one, sodium. Sodium Na. That's 2 to 8 to 1. Then to write the configuration, we have 1s2, 2s2. We are going to 11. Now 1s2, 2s2, 2p6. Look at it. 6 plus 2, 8 plus 2, 10. It remains 1 to make 11. After, then we now go to what? 3s. 3s. But it's 1 that remaining. We put the 1 there. So we are done with that. Then the next one, number 12, is magnesium. Magnesium Mg, which is 2 to 8 to another 8, to 2. The configuration is now what? 1s2, 2s2, 2p6, 3s2. So, and now add them together. 2 plus, that's 8, 9, 10, 11, 12. Now, then the next one is aluminium. Aluminium, Al. That's 2 to 8 to 3. Configuration will now be 1s2, 2s2, 2p6, 3s2. Now, add up what you have here now. This 6, 7, 8, 9, 10, 11, 12, and you are going to 13. And s is full. 3s is full. You now go to 3p and put the remaining one there. Although the 3p can take 6, but it's one that is available, so you manage it like that. The next one is silicon. Silicon Si, which is 2 to 8 to 4. Then the configuration will now be 1s2, 2s2, 2p6, 3s2, 3p2 to make. So the next one is phosphorus. Phosphorus. Phosphorus P. That is 2 to 8 to 5. And the configuration will now be what? 1s2, 2s2, 2p6, 3s2, 3p3. Then we continue from there to number 16, sulfur. Sulfur S. Configuration is 2 to 8 to 6. Now, then the SPDF notation will now be what? Start writing it before I will write to show that you are following me. Start writing before I will write it to show you are following me. Now, let's go. Let's go. We're now having 1s2, 2s2, 2p6, 3s2, 3p what? 4. We'll still continue to put it in that 3p because it can take 6 until when the 6 is complete. Next one is chlorine. Chlorine Cl, which is 2 to 8 to 7. It will now be 1s2, 2s2, 2p6, 3s2, 3p5. Then next one is argon. Argon Ar, which is 2 to 8 to 8. Configuration will now be 1s2, 2s2, 2p6, 3s2, 3p6. So, you can see, yes, that is 18. Now, number 19, now, which is potassium. Potassium. Now, number 19, which is potassium. Potassium K. Configuration is 2 to 8 to another 8, then to 1. Then configuration will have 1s2, 2s2, 2p6, 3s2, 3p6, then something comes here. We have 1s2, 2s2, 2p6, 3s2, 3p6. After 3p6, what do we have? We are supposed to have 3d. And lastly, we have 4x. But I explained something to you in the very first video. The reason why potassium and calcium, despite the fact that this share, this is KMN, that share can carry 18 electrons, but it behaves like this share that it is carrying 8. After 8, we go to the next. Why? I told you, in that share, there orbital that has the capacity of carrying 10 electrons. That is 3D. But it is bad. It is not usually filled with electrons. So we will now have 3D0 and 4s1. But it is better to write it as 1s2, 2s2, 2p6, 3s2, 3p6. Omit this one. Anything less than 0 is 1, is unity. Then you come to what? 4s1. So for potassium and calcium, there is no 3D. The 3D is there, but it does not carry electron. So the number 20th is calcium. Calcium Ca. The configuration is 2 to 8 to another 8 to 2. Now, writing the configuration, 1s will carry 2 electrons, 2s will carry 2, we are going to 20. Then 2p will carry 6, that's 10 already, 6, 7, 8, 9, 10. Then we go to 3s is carrying 2, make it 12. 3p is carrying 6, 6 plus 12, that's 18. Then, since this one is carrying 0 electron, we just go to 4s2. So that is that for that. So if you add up this power now, you end up getting 20. So in that place, this is K shell, carrying 2 electrons. This one, anything 2, is L shell, carrying 2 plus 6, that's 8. Then anything 3, this one and this one, is this 8. 2 plus 6 is 8. So this one is 2, this is 8, then n is what? Is also 8. Then we now have what? Ratio what? Ratio 2, which is this. That's how we have 2 to 8 to 8 to 2. 2 to 8 to 8 to 2. So that's how we have what we have here. Now let's proceed to the transition elements. The transition elements. The transition elements that is from scandium to zinc. From scandium to zinc. From 21 to 30. They are called the first transition element. When we get to periodic table, we'll talk more about that. Number 21 is scandium. Scandium. Scandium Sc. And the configuration of, go and visit the first video. That's 2 to 8 to 9 to 2. I told you that this man can take 18. We put 8, but by the time you get to scandium, they now start to repair. They repair one of the seats inside the 3D. So the configuration will now be 1s2, 2s2, 2p6, 3s2, 3p6, then 3d1, 4s2. You can see that the 3d we omitted here is carrying 0 for potassium and calcium, is carrying 1 for scandium here. So that is it. So 22 now, we have titanium. Titanium Ti, 2 to 8 to 10 to 2. You can, to understand this, visit the very first video. We have 1s2, 2s2, 2p6, 3s2, 3p6, 3d2, 4s2. I told you that the increment is on this shell because it is the 3d that we are filling last. Despite the fact that it is not the last orbital, but we fill it last. 23, scandium, titanium, then is vanadium. Vanadium V. So we have 2 to 8 to 11 to 2. Configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d3, 4s2. All of them end in 4s2, except copper and chromium that end in 1. Now, number 24, chromium. Chromium Cr. That is 2 to 8. It's supposed to be to 12 to 2. No. But it ends in 1, except and copper. Let me start it. So it ends in 1 and double fill this one. The remaining one, they put it here. Instead of it to be 12, it's now 13. And the conversion will now be 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s1. It's supposed to be 3d4, 4s2. But except and copper, they end in 1 and add 1 to this 4 to make it for 3d5. So that is that. When we get to Ohm's rule, we understand better. 25. You have manganese. Manganese Mn. The configuration is 2 to 8. It's supposed to be 13, then end in 2. But this, so we now have 1s2, 2s2, 2p6, 3s2, 3p6, pieces, 3D is one that's supposed to have 3D5 and end in 4s2. So that's that. If there's any question, you can call me, you can put in the comment section. After manganese is iron. Iron Fe. Iron Fe is 2 to 8 to 14 to 2. Then it's 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d5, then 4s3. Supposed to be 3d6, then 4s2. So that is iron. Then after iron, number 27 is cobalt. Cobalt CO, which is 2 to 8 to 15 to 2. And it's 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d what? 7, then 4s2. Now, after cobalt is nickel. Nickel Ni. That's 2 to 8 to 16 to 2. And configuration is 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d8, 4s2. Now, let's now look at copper and zinc. Now, number 29, I want to start it again. Copper. Copper is Cu. 2 to 8. This one's supposed to be, after to 8, it's supposed to be 17. And end in 2, but no. It end in 1 here, and double feed this one, add 1 to this to make 18. So the configuration is now 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d. It's supposed to be 3D. Since this one is 3D8, it's supposed to be 3D9, 4s2. But no, it's supposed to be 4s2, but no, it ends in 1 and add 1 to this 9 to make it 10. So that is its own abnormal behavior. Then the last one, number 38, is zinc. Zinc Zn. Configuration of zinc is 2 to 8. It's supposed to be to 18 and half 2 ending. Now, configuration will now be 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3d is supposed to be half 10 and 4s2. So we are done with that. I want to now show you some special cases with a classwork. Some special cases with a classwork. Now let's look at this classwork. They say write, number 1, the electronic configuration of the following ions. Number 1, they say ion 3 ion, which is Fe3 plus. Okay, let me say ion 3. Let's say ion Fe26. Then number 2, they say ion 3 ion, which is Fe3 plus. Then number 3, calcium Ca20 and calcium ion, that's a Ca2 plus 20. Then number 5, you're asked to write for sulfide ion, which is S2 minus ion. Okay, let's consider sulfur first. Sulfur atom, which is S16, and sulfide ion, which is S2 minus. So we want to write the electronic configuration for this. What do? This is what we have done before. 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2. 3d what? Let's add up. 2 plus 2 is 4, plus this 10, 11, 12, 12, 13, 14, 14 plus 6, 14, 15, 16, 17, 18, 19, 20. So to make 26, we add what here? 6 here. So that is that. We have done that before. But when it is now ion, 3 ion, when it is ion, this 3 ion, this 3 plus it shows that it has lost 3 electrons. So you now cancel the 3 electrons. This 4s will be part of it. This 2 will go. Then 1 from this 6 will go. This one will now be 3d5. So it will now be 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. Now, because it has lost 3, 4s has done with its 2, then only 1 from here. Then quantum is 20. That's a 1s2, 2s2, 2p6, 3s2, 3p6, no 3d like I told you, 4s2. But what then happens when it is calcium ion? Calcium ion will now be 1s2, 2s2, 2p6, 3s2, 3p6. Now, 3p6, if it loses 2 electrons, then the 4s that is carrying the 2 will go. You start from the back. Then sulfur, 16, 1s2, 2s2, 2p6, 3s2. Let's see whether it is 16 already. From here to here is what? It's already 10. 6, 7, 8, 9, 10, 11, 12. So then we still proceed to what? 3p. So if this is 6, this is 10, 11, 12, 13, 14, 15, 16. So we need 4. So 4 will stay here. So that is that. But what about sulfide ion? Sulfide ion means it has what? It has, these 2 minus means it has borrowed 2 electrons. When you have negative, opposite of negative is addition. When you have positive, opposite of positive is what? Minus. So because you have 2 minus, you will add 2 to what we used to have before. You now have 1s2, 2s2, 2p6, 3s2, 3p, add 2 to 4, 6. So that is what you have done there. Then another class work, number 2 of this is that you can say write shorter configuration for the following. Number 1, calcium, Ca20. Shorter configuration. Calcium is supposed to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. But shorter, you now locate noble gases, the noble gases we used to have. Helium is a noble gas. You can write something like this, He, to represent this 1s2. Put it like this. Then rewrite the remaining things here. 2s2, 2p6, 3s2, 3p6, and 4s2. You can also say, okay, I don't want helium, I want neon. That's 10. 6 plus 2 plus 2, that's 10. From here to here can represent what? Neon, Ne. Then, that is from here to here. Then, write the remaining things here. 3s2, 3p6, 4s2. You can decide to say, okay, it's argon I want. Argon is number 18. So you have 2 plus 2 is 4. Plus 6, that's 10. 10 plus 2, that's 12. 12 plus 6, that's 18. So from here to here is argon. Then just have what? 4s2 there. Just have 4s2 at the back here. 4s2. So that is that. You have Ar 4s2. So that is that. So I think we have come to the end of this lecture. Please do try to subscribe in my YouTube channel titled Afe Ademola Johnson, and subscribe so that you have access to very good information that can benefit you rather than pranks. and God will help you. Now, try to share my videos, like it, and put in the comment section a word of encouragement if you don't have any question to ask. Of course, if you have any question, you can put it there. And if you have any question, you can call 070 30 39 35 31. That's my WhatsApp number. You can WhatsApp me, you can send voice notes to me, you can call me for any explanation, then I will give it to you. See you in the next video, where we are going to look at Ohm's rule of maximum multiplicity. Don't forget, in the previous video that we did, we said we started talking about the laws governing electronic configuration. We have talked about Heisenberg uncertainty. We are just finishing Aufbau principle. In the next video, we will go to Ohm's rule of maximum multiplicity. See you there. God bless you. I remain Afe Ademola Johnson. Share the video, like it, and subscribe in my YouTube channel. I will see you at the top, and God will bless you. Thank you. Bye for now. God bless you.